Hi, this is Maggie. In this video we're going to talk about inheritance in object-oriented systems. Inheritance refers to a hierarchical structuring of classes. This sort of categorization into hierarchies comes pretty naturally, I think, because it is how we organize things in the natural world. For example, we organize living things into kingdoms, and then within each kingdom there are further divisions to organize the life that has been observed on Earth. An example that's often used when describing inheritance in programming is an animal hierarchy with animal at the top as a general category, and then dog, cat, fish, bird, for example, as being specializations of animals. And there are certain things that all animals do, such as eat or sleep, but each specialization might do those things in different ways. And then there are things that the specialized animals can do that the others can't, and that the generic high-level animal can't do, such as fly for animals in the bird category, or breathe underwater, I'll say, for the fish category, broadly speaking. In object-oriented programming, inheritance is a way we can define a generalization class and then specializations of that class. Let's use an example of content items on a website. In our example, we want to be able to construct a web page composed of different content items, such as articles, advertisements, and images. In the future, we can imagine that we might want to add a new kind of content, such as a quiz or a survey. If we think about designing something like a page class, which is the object that manages and displays all of this content, the page class might only be concerned with organizing the content on the page and then reorganizing it if the browser window is resized. It might be concerned with getting dimensions from a content item object, setting its location, and asking it to draw itself. It is not concerned with what the content actually is. But if we think about content creators, the folks putting the publication together, an ad, an article, and an image are three very different things. They contain different kinds of content, and an ad, for example, might animate as it displays itself, as annoying as that is. So they behave in different ways. If we extend the system and include quizzes and surveys as content items, they also behave in different ways. So one option would be to incorporate all of these different kinds of functionality into one content item class. That would be large and messy. Imagine handling a click. If the kind of content you have is article or image, you ignore the click. But if it's an ad, you shoot the user off to the owner's website. Behaves like a link. And if it's a quiz or a survey, you're going to respond to the click by changing the appearance of a control maybe, or telling them which planet in the Star Wars universe they'd most like to live on. And if the publisher then decides there's going to be a new kind of content, such as an interactive statistical display, I've seen some really cool ones on news sites, then you have to rewrite every single part of the content item class that needs to behave differently for the interactive display. You'd wonder why you have an object-oriented design in the first place, because that's not very object-oriented. Suppose you write them all as different classes. That makes more sense. But then you would have to give them all the same messages that the page wants to send to them, handle, click, draw, and move, for example, and you'd have to write and rewrite the methods for all of them, even if it was the exact same code. And as the saying goes, copy and paste is usually a design error. If you need to change one, you probably need to change them all, multiplying your chances for making an error. It also, in most languages, shifts a huge burden to the page class, although not so much in Python as other languages, so we won't talk about that particular disadvantage. What we need is to have a public interface that all of these different objects can share with the page class, and then private implementations that are unique to the different kinds of content. And the way we do that in object-oriented design is with inheritance. I can have a content item class with the public interface that the page class needs to do its work. And then I subclass the content item class with, for example, image, article, and ad subclasses. So here's an association class diagram showing these relationships. The page class has a composition relationship with the content item class with one page to many content item objects. But article, ad, and image have an inheritance relationship with the content item class. That is drawn with an arrow pointing from the subclass, also called the derived class, to the superclass content item, also called the base class or sometimes parent class. You can infer from the way the diagram is drawn that page only knows about content item. Page has a has-part relationship with content item. And article, ad, and image have an inheritance or is-a relationship with content item. And ad also is a content item. Okay, so in practice, we write the page methods so that there's this collection of some sort, maybe a list of content item objects. And it talks to them through the public interface of content item, maybe including handle, click, draw, and move methods, and that's all page ever sees or knows about. And when we write the methods for content item, but we define these different kinds of content item objects, and they might have different behaviors and different data in addition to whatever a content item has. And we can add new subclasses, and the page will be blissfully unaware. As long as the public interface for content item is still sufficient for page to do its work, we can extend the system pretty easily. So to finish this discussion of inheritance, let's just look at the syntax of how to define these classes, and then we'll go on to talk about how different behaviors are actually implemented in the next video. So what I have here I'm calling minipub, because this is just a text version of the page class, the content item class, and the add class. And I've only written a few methods here to show how we program inheritance. To start, I have the content item class, and there are no surprises here, as we've seen classes defined before. It has one field, which is private, called content, and that's of type string. And in init, it is passed a parameter, and it initializes its content field from the parameter. And then we have an str method, which just returns content. So that's very straightforward. But here's the add class, and this is where it gets interesting, because add is a subclass of content item. An add object is a content item object. So that looks like class add, and then in parentheses, content item. The add will have a field called URL, which is a string and is private. And that will be the URL that you will jump to if you click on the add, although not in this text-only version. We'll use that in the next iteration of this program. So an add actually has two fields. Content, which it inherits from content item, and URL, which is unique to an add. And that information might help with understanding the init method, because notice we pass in two parameters, content and URL. And the first line of the initializer is a call to the superclass initializer, super open paren close paren dot init, and then we pass in that parameter content. So we don't do anything with that here in add. It's not really add's business. It is, but it isn't. It's part of the add, because an add is a content item, but it's a part that is private to the content item methods. We need to let the content item deal with it, and we'll deal with URL down here in add. So after passing content up to the content item initializer with the call to super init, we set the URL field to the parameter. And here's page, and this is an aggregate relationship with content item, which is not a surprise, hopefully. It has a list of content item objects and an initializer in which it sets that list to the empty list, and an add item method which takes a content item object as a parameter and adds it to the list, and a show method that iterates through the list and just prints each item. That will, of course, implicitly call their str methods. Okay, so the only thing that might feel a little weird about that is you've got a list of content items in the page object. What happened to the add objects? What if we want a mix of content item and add objects on our page? Remember that an add object is a content item, and so you can add an add object to that list, and because it is a content item, the page just interacts with it through the public interface of content item, and it never knows that it's actually an add. And you can see down in our little client function main, we create a content item, we create an add, and we create a page and send it the add item message with the content item, and send it the add item message with the add, and then send it the show message. And when we run it, it displays both of the content items that we added to the page. It interacts with the items in its list through the public interface of content item, which, in this case, is the str method. So hopefully you see a little bit when we use inheritance. It is a way to create an extensible hierarchy of classes that can interact with the rest of the system through the public interface of the superclass at the top of the hierarchy. And you see how we put the superclass name in the subclass definition, and we use super when we need to call a superclass method from a subclass method. Superclass methods are responsible for the private parts of the superclass implementation, and the subclass methods are responsible for the parts of the implementation that are unique to the subclass. To practice with this, add another subclass to this hierarchy, for example, an alert, and give the alert a date field, like in the assignment class in listing 5.2, representing when the alert was issued. In the main function, create an alert and add it to the page, and confirm that everything works properly. When you can extend this hierarchy successfully, you're ready to move on.